Hello everyone, and in this video today, first I will talk about import point attributes. Second, I want to talk about point cloud open. Third, I want to talk about point cloud filter. And these three are new to us, so I will go through each of them and I will explain these three in detail. And at the last, I want to start with our VEX vector expression language, and by VEX we will create some attributes on our geometry, and I will just start it and it would be very basic, and I created some of the nodes for you. But first we will create our project and we will understand these three VOP nodes, then we will review our nodes also. So let's start with our video. And first First, see, as you see, I have created a small project, and here I have created some nodes. And inside this attribute, we will create something like this, and these are the nodes, and we will go through each of them, but later. So first, let's create our project and understand each of these VOP nodes one by one. Okay, keep this side. Let's create a plane grid. Okay, I have this grid. Increase the rows and columns to 1000. If your computer can handle this much primitives, then it's okay. But let's get back to 100 and 100. And now what I need to create a sphere also, but here the sphere is primitive. I want to create a primitive sphere. So what is primitive sphere? First I want to talk about this, and we can say that primitive sphere is a point with a radius, and Houdini is displaying the primitive, but it is not real polygons. It is not made up of polygons, so it is only one point. It is just one point, and I can show you. Go to wireframe, and here you can see this is our radius. This is our radius, and we have a point location. Here you can see our point, and we have only one point, but no primitive, right? Go to the geometry spreadsheet, you would see only one point at the point level, and we have nothing. So what we have here, we have a point, we have its location, and we have a radius of this point. So Houdini is just saying that this point is located at this location and it has this radius, and let's create a display. So we can create a mesh over that, but it is not made up of, it is just to display, the sphere. So when I go to smooth wire shaded, we see this looks like primitive, but it is not made up of polygons. It is just to display our primitive sphere. Let's create an attribute VOP node and connect this one first, and I have created the primitive sphere node so we can have a better understanding. It is exactly what I said. Primitive sphere, a sphere with radius x located at xyz, not a list of hundreds of points. We have only one point. I will display, and Houdini is now saying I will display the sphere shape even though it is not built from geometry. This is not built of polygons, but we have a sphere shape. We have a sphere shape, but it is not made up of polygons, and it is just one point. Okay, and I want to talk about these four inputs here, and I think I have talked about this in the last video, and I want to talk about these again. So first input is our input for the geometry we want to modify, right? The first input is the input for the geometry we want to modify. So this grid is now connected to this first input. That means this grid is now modifying. We can modify this grid, and these three inputs are inputs to reference some other geometry. What do I mean by that? When I am connecting this sphere output to this attribute VOP input, now this sphere is being referenced. We can import, we can reference, we can import the attributes from this sphere by this. We cannot modify this, we can just take some reference, take some values, but we cannot change anything. And I have also created I've created a knot. So let's bring this knot here. You can say input 1 is geo to modify, second geometry to read from. So we are reading the attributes from this sphere into the second. You cannot modify the geometry, yes, but you can read from it. So we can read the attributes values, we can read this geometry, but we cannot modify this geometry. To modify, we need to connect this into the first input so we can modify this sphere, but now it is connected into the second input. That means we can reference the values, or we can read the values. You can say both. This is to read and this is to modify. Okay, let's dive inside this. Here we have our two VOP nodes, right? And I was sorry, this is a SOP node, right? I was saying VOP, I guess. This is a SOP node. Inside this, these are VOP nodes. And now I want to talk about the import point attribute VOP node. Let's create our import point attribute node. And this node does what it says. It imports point attributes. So in this case we have output 1, output 2, output 3, and output 4. So our sphere is in output 2. That means we want to read from this sphere 2, because this sphere is only to read the attributes from this sphere. This sphere is giving up some values and we can read those values. And inside this, we have import point attributes, so we can read from points and we can read the attributes from points. And we have single point, that's why I created a single point so we can read it easily. We have PT number is point number, so we can provide a value to read from. Like say we have 3 points, but we only want to read from the second point, so we can give this value 2, so we can have the point number to read from. We have file, we need file. File is the geometry we are reading from. So in this case, we are reading from input 2, connect this to file, and when you go here at the geometry level, you see sphere is an input 2, so we are reading from the input 2, right? Okay. Now what we need, this sphere has only one point, and which is at the center. So we can give this a number, but you see we have this sphere and give this an attribute. It doesn't have any attribute right now. It just have one point. So let's give this a color attribute. Now we can see our point is colored in purple. Okay, close this, and now we have our CD, our GB, and it's a vector. So inside this, let's read this point. Connect the result into the CD, because we want to output this value into the CD value of the grid, so we can change its color, because this sphere has only one attribute, and which is CD. So we can only read from that the CD values of that sphere, and I outputted it into the CD, so we can give our grid this color. Now you see it is black because we didn't give this from which point to read from. Let's give this a constant, and this constant, connect this PT number, and when you say give this attribute CD, because we want to read the attribute CD. Okay, now when you say this point has one value, one is, there is no point with point number 1. We only have one point and with whose value and its value is 0. And I can show you where this sphere, right? I guess you know, right? This sphere has one point which is 0, and you can see it here. We have one point and its value is 0, right? You see 0? Okay. We have this. Now we can see now our attribute from the output 2, which is the sphere and its point. So we are now reading, we are importing the attribute from the point, and we have connected the attribute from the point to the CD of the global input, which is the grid. Okay, I think this is clear because it was really simple. And now I want to read this sphere point values, but only for some specific points. Let's say this sphere right now exists here at the center, right? And our grid center is also at the world center, right? So I want these points to only influence by the points, like by the sphere point. What I want to say here is this sphere point has the attribute CD, right? Okay. Now I only want this area points to have that color attribute. And how can I do that? Okay, we have this point cloud and open. So now what is this point cloud open? What is point cloud? So for example, you have this 3D space and we have lots of points, millions of points scattered. This is point cloud. And this point cloud have file P and P channel, N channel, radius, cone, preload, max point, a lot of attributes, lot of parameters, and lot of ports. Not attributes, but we need, like, it has some defaults attributes we can read from, but we need only P and file. File is to the geometry we want to read from, and that is input 2, and we have this P. So why do we need the P of this grid? Because what I'm saying here is I want some of my points to get the attribute CD. Only want some of the points, but which points and where they are located. So because we need these points, we need those point numbers, right? That's why we need these point positions and their number, so we can know which point and where they are located. And when I connect this to the CD, we see black because this PC open only gives us point numbers. What do I mean by that, and how this file and P are like connected? Okay, what this PC open is doing here. Okay, this PC open has search radius. So this PC open is like, tell me the nearest points. Tell me the nearest points. And when I have given this a P, a point position vector, so this knows where each point is located. So all these points of this grid, because we are like, we have connected the point position P into the point position of this PC open, so now it is reading the point positions and their position values. And now all these points are like searching around themselves. Like, let's say you have a point, and now this point, the points of the grid, you have, let's say this point, this is a point of the grid, and now this point is searching in this space around itself, and it is searching for a point of which geometry, and the geometry we have provided it is our output to, which is our sphere, right? So we have file and P, position is like the point position, and all those points are now searching around themselves, and they are searching for a point of which geometry, and the file is input to, which is our primitive sphere, right? Primitive sphere has only one point, so now all these points are searching for that one point. We have given this a search radius, so these points have limitations. These points have a radius to search in. Okay, now I want to also tell you what this PC open, PointCloud open outputs. It outputs those points number. It don't read attributes, it only reads point number. And what do I mean by that? When you give these grid points location and the geometry to read the points from, so this is only saying I want to read my surrounding points. I only want to know which point is located, like which point is located in my surroundings. I only want that point number, only point number. And so these grid points are now searching in their environment, in their nearby location, and these points have a radius. They are like bound to this radius value. When I say 1, search in 1 unit of the radius around yourself, you can search 1 unit in any direction. So they are like searching 1 unit in their space. Now this point handle is giving us the nearby point number, not attribute. It is not reading attribute, it is only reading the point number. And when I connected this CD, it is only giving a point number. So CD need something. CD need some value. You see 0 because our point is 0. Our point is 0. Our point number is 0. And when I say PC filter, this is point cloud filter, and here we can tell this number which attribute we want to read it from, which attribute we want to read from that point, right? PC filter, it filters the attribute. I have this P, but we want CD. This point filter is now filtering which attribute we want to read from that point. I'm saying CD. When I connect this into the CD, now we see something. What? I have said that these points, wait, I will tell you about this also. So these points are searching around themselves in 1 unit radius, because the search radius is 1. and only these grid points can find this point, our sphere point, and this sphere point has the attribute CD. Now we are filtering that CD attribute, and the values that are coming from that is going into the CD. That means, I will say it again, these points are searching around themselves, right, in the 1 unit radius, because the search radius is 1, and only these points can find. These points cannot find because this point is too far from them. It is not like in the 1 unit radius range. That's why they cannot read this point CD value, and only these can read. And when I here is the cool thing, when I move this sphere, let's say in x-axis, you see now these points can read, but these cannot, because now this point is like out of their radius range, right? You can move this, and you know why they are reading but they are not reading. Now I also want to talk about when I disconnect this. When I disconnect this and wait a second. When I disconnect this and go here, and okay, I like translated this sphere back to the center, because I want to tell you a really cool thing here. Now when I disconnected this P, now these points are reading, but what is this? Now why all these points have the CD attribute? Why all these points have the CD attribute same? And I want to share something here. When we disconnected this point P, now what is happening here? First we connected this, so these points were reading in their 1 unit space, right? And we knew where each point is located, but here we don't know what are their location, what is their location. We this don't know what are the points location and their like point number, right? Because this P gives the position vector, so it doesn't know where the points are located. So because it doesn't know where the points are located, now what is happening here? All these points are searching for the sphere point from the center, 0 0 0, from the center. When we haven't connected this P into the P, now this node don't know where the points are located. That's why all these points are now searching. All these points are now searching for the input 2 primitive point from the center. And what happens from they are searching from the center? What happens if this point goes far from that 1 unit radius search range? Do that. Let's say in the x, and you see when I am minus 1.1, now all these points searching from the center, right? Now they cannot find the point because they are all from this searching from the center, and this point is now far. This point is now 1.1 unit far to the center, from the center, right? That's why they cannot find this point. And when I take this back at the center, they can find it. When I move this up in the space, let's say 1.1, they cannot find this point, but inside the 1 unit range they can find it. And I want to tell you something also. I want to share something here also. One more thing. Connect this. And this spacey filter gives you the average. Gives you the average of the attributes. What I mean by that? What I mean by that? We only have one point, so they are all reading from this point. But what if we have 2 points in the search radius unit 1, and those 2 points have different values? So what would happen? What would happen? I want to show you what would happen. Here, let's create another sphere, another color, and give this color, let's say, yellowish or darkish. We can have some dark or light. We can say dark yellowish, light yellowish. Light would be better. And give this merge SOP node and connect this, input 2. Now what is happening? I will show you what is happening. And move this sphere, let's say here, okay, or minus in minus, okay, okay, here. Now we have two sphere, or not in minus, so we can have a better understanding. Move this in the X location. Yes. Okay. Now what is happening here? Why these points have this mixed color? Because this PC filters the attribute which we want to like read. But when I'm saying these points read your surrounding, and if you find a point in the 1 unit radius, tell me, and I will tell this PC filter that I found these 2 points. Okay, now we have 2 points in the search radius of these points. This point, these points can find this, these points can find both, and these points can only find this point, right? So now they are like, what's the word? They are like getting influenced by these points. Now this point CD attribute is now transferring to these points, and these points, this point CD attribute is now transferring to these. But these points have both. But what both? So the value coming from this and this are now being averaged. So this PC filter gives you the average. If you have 2 points and they have different CD values, so it would do the average, and it would like give, and it would output this value, and you can use that value into your CD input output VOP node. So I hope you understand this, and this is it for the VOP. Let's review our notes, right? Okay. Let's PointCloud filter. Let's say, what is PointCloud filter? PointCloud filter returns the average of an attribute from all nearby points. As we are seeing here, the CD attribute is now being averaged here, because these points find two points and they have different attributes, so the attribute is now being averaged here. And in this case there is only 1 point, so 1 point, because there was only 1 point, so the average value would be the same, because there is one value, right? Okay. And when I created this, let's toggle this on, and inside this, wait, okay, we have this and we have this. Okay, inside this, when I like connected this P, we see nothing because our sphere is really small here. But when I disconnected this, what happened? And here is the answer. What happened? When you don't connect anything into the P of the PC open, now what is happening? At the world center, find nearby points and input 2. So now all these points are searching from the world center. So every point of the grid is now getting the results from the world center. They are searching from the world center, and now all the points of this grid getting the result from the center of this world. PC Open does not read attributes, as I said. PC Open only does one job. It returns a point cloud handle which is basically a list of point numbers. This handle only giving us a point number which like it found in the nearby search radius, right? Okay, example, if you have plain points, find nearby three spheres, PC Open would give 0.5, 0.8, 0.10. So it only gives point number it can find nearby. Point cloud, a collection of point in space, millions of tiny dots floating in space, we can say, and we say it point cloud. The point that we connected into the P are now searching for nearby points. They are searching for points near them from the file. These points searching from the points from these output to, which is our geo we are reading from. Output are geo source with geo stream input SOP to read from. Input stream input SOP to read from. Output are geo source with geo stream input to read from. So we are basically reading the attributes from our input geometry. I guess this is just it for the VOP section. Now let's create some VEX, some attributes through VEX, and I have created another geo container, and I have like created some vectors expression so we can understand this. And so I've already created this because I don't wanted to waste your time. We will start the VEX from tomorrow, and in the next tomorrow's video I will start with the VEX and I will explain each in detail. For this class, only understand what are integers. Integers are 1, 2, 3, 4, 5, 0, whole number, right? Float are 1.1, 1.0, 2.3, 4, 5.6. Values in points, like we can say what's the word? The word fraction, right? So these values are in fraction. That's why we are getting the points values, and that's why we call them float, because they are in point, they are in fraction. Vector, we have x, y, and z, and in VEX we express the vectors by these brackets. This is just syntax we are using. They have some like rules, we cannot break those rules. And CD, we have RG and B. CD is also a vector. String is text, simply basically text. We have CD text. If we are giving a geometry a name, it is string. And we have some examples. I have created some examples for you. I integer @attribute, new attribute, it was the name. And just read these so you can like have the image of these basic VEX codes. And I will continue this from here, right? I have created this so you can have the idea of the VEX. And let's end this video here, and from tomorrow we will continue our series with a different part, and that part would be VEX, right? So that's it, and I will see you in the next part, and until then, take care.